One application of the law of cosines is what's called Heron's formula. And Heron's formula is a formula that the formula itself doesn't involve trig, but it's derived from using the law of cosines. The proof is in your book on page 309 if you want to read about it and look it over. Kind of an interesting proof. But Heron's formula says if we have a triangle and we know the lengths of all of the sides of that triangle, then we can find the area of that triangle. We know our general area formula for, I'll use capital B for base, for a triangle is 1/2 the base times the height. But if we don't know that perpendicular height, then we're out of luck. We also know that from one of the last sections, that if we know two sides in the included angle, then we could use a formula that involved a sine function. Neither of those cases apply here. We don't have enough information to use either of those if all we know is the three sides of the triangle. So if we know the three sides, we can let S be the value that's half the perimeter, or we could call it the semi-perimeter. And then the area of that triangle ends up being a mess. S times S minus A times S minus B times S minus C. The square root of that product is the area. So let's find the area of one triangle using Heron's formula, that triangle that we were just working with on the other video. If we want to find S, half of the perimeter, or the semi-perimeter of that triangle, we add up the sides and divide by 2, which is 11.5. The area of the triangle then is going to be S times S minus A. So 11.5 minus 9 is 2.5. S minus B. 11.5 minus 3 is 8.5. And S minus C. 11.5 minus 11 is 0.5. If we multiply all those numbers together and take the square root, I didn't write down what the product is underneath there, but to 2 decimal places we get 11.05. The area of that triangle is 11.05 square units. And Heron's formula is something that we use it in our tech math class. It's used in other geometry classes. It's handy to have in the back of your mind if you need it. And again, there was no trig involved in doing this computation here, but the trig is involved in coming up with that formula. So I just thought I'd show you an example, and let me know if you have questions.